Today we are going to talk about Little's Law. It is one of the simplest but most powerful formulas for understanding flow in lean processes and operations. John Little, a professor at MIT, formulated it to show how three key variables are always linked. Work in progress, which means how many items are currently inside a system. Throughput rate, which means how fast items leave the system. Lead time, which means how long it takes before an item is completed and delivered. Little's Law says lead time equals work in progress divided by throughput rate. This relationship always holds in stable systems. Stable means the inflow and the outflow are roughly equal, and there are no big spikes, shortages, or special events. In other words, it is valid in everyday operations, not during ramp-ups or breakdowns. Let's see a basic example. A repair shop has 20 phones waiting for service. The technician repairs 5 phones per day. How long will the last customer in line have to wait? Lead time equals 20 divided by 5. The answer is 4 days. Now let's look at another form of the law. Sometimes instead of using throughput rate, we use cycle time, which is the time needed to process one single item. Then the formula becomes lead time equals work in progress multiplied by cycle time. We can test that with numbers. The repair shop now has 60 phones waiting. The technician repairs 6 phones per day. A working day is 480 minutes. Cycle time equals 480 divided by 6 equals 80 minutes per phone. Lead time equals 60 multiplied by 80 equals 4,800 minutes, which is 80 hours, which is 10 days. Exactly the same result as with the other formula. This is why Little's Law is so useful. You can use whichever version is more practical for your data. Here are several ways I use Little's Law in lean manufacturing. Example 1. Calculating queue time. I have 10 items in work in progress. Cycle time equals 30 minutes per item. Lead time equals 10 multiplied by 30 equals 300 minutes, which is 5 hours. So the last item will wait 5 hours before being processed. Example 2. Finding the maximum work in progress to meet a given lead time. Cycle time equals 20 minutes. Target lead time equals 6 hours, which is 360 minutes. Work in progress equals 360 divided by 20 equals 18 items. So I should not allow more than 18 items into the process if I want to meet my waiting time goal. Example 3. Determining the maximum allowable cycle time. Target lead time equals 120 minutes. Maximum work in progress equals 30 customers in the waiting room. Cycle time equals 120 divided by 30 equals 4 minutes. The process must not take more than 4 minutes to hit the target. Beyond manufacturing, Little's Law can be applied in many areas. In hospitals, it can estimate patient waiting times in emergency rooms or operating theaters. In call centers, it can predict how many operators are needed to keep call waiting times within targets. In software development, it can be used to manage backlogs and predict delivery times for features. In supply chains, it can guide decisions on stock levels, lead times, and throughput at warehouses. You can also use it for line design. If you know your target lead time and your process speed, you can calculate the amount of work in progress you should allow to achieve smooth flow. Or if you know your work in progress and your customer promise, you can calculate the cycle time that each operation must meet. Little's Law is not a forecasting tool. It does not tell you how to change the future. It tells you the inevitable relationship between these three variables. Change one, and at least one of the others must change too. In short, Little's Law is a compass for lean thinking. It helps you make better decisions about capacity, flow, and customer experience, whether you work in manufacturing, services, or knowledge work. Thank you for watching this video about Little's Law. I hope it gave you some clear and practical ideas you can apply in your own processes. If you found it useful, give it a like and share it with your colleagues. And do not forget to subscribe so you will not miss the next video. In the next episode, we will dive into Kanban, the visual system that helps teams control work in progress, limit overload, and make flow visible. It is a perfect companion to Little's Law. See you there.